Hello everyone, welcome back to my channel Power Tech Academy. Today I'm going to continue with backup relay coordination, and I'm going to use a smart relay. So instead of electromechanical relay, which I used in my previous presentation and simulation, I would like to use a smart relay 501. So I'm doing the simulation and I'm trying to calculate the backup or coordination for the backup relay exactly for the same circuit. The main difference here is instead of electromechanical relay, I'm using a smart relay and the relay curve is C2 and C2. Tap setting for the first relay is equal to 5 and time dial is equal to 0, 1. And I need to calculate tap and time dial for the backup relay. So I can use the short circuit summary report, which I prepared for the same circuit. And as you remember, the minimum current line to line between bus B and C was equal to 1179, and maximum current three-phase fault was equal to 2834. So I'm using the same method. I need to use the minimum fault current to calculate the tap setting for the backup relay, and I'm using the maximum fault current to calculate tap setting. So minimum fault current is equal to 1179. CT ratio for backup relay is 1000 to 5. So backup relay current is equal to 5.895. Best modes is something between 2 and 1.5. If I assume 2, my tap is equal to 2.94. If I use 1.5, my tap is 3.93. Is a smart relay, so tap setting can be adjusted with accuracy 0.1 amp. So between 2.94 and 3.93, I prefer to use 3 amp as a tap setting. To calculate time dial, first I need to calculate the trip time for the main relay. Curve is C2, and this one is the formula for C2 curve. Maximum current is 2834 amp. Turn ratio for main relay current transformer is 100, 500 over 5. So the main relay current is equal to 28.34 and tap is equal to 5. So modes is 5.66. And time dial for this relay is 0.1. So 0.1 multiply 13.5 over 5.668 minus 1. The trip time for the main relay is equal to 0.289 seconds. So to calculate the trip time for the backup relay, I need to add CTI, coordination time interval. So definitely a smart relay is faster and has less error compared with electromechanical relay. So I prefer to add coordination time interval equal to 0.2 second, and circuit breaker operation time based on question title is 5 cycle plus 5 over 60. So trip time for the backup relay is equal to 0.5723 seconds. So the backup relay is using C2 curve. I have the trip time, and also I can calculate the mode for the maximum current 2834, CT ratio 1000 to 5, relay current excuse me 14.17, and selected tap is equal to 3, so mode is equal to 4.72. So I have the trip time, I have the mode, I can calculate the TD time dial. So based on my calculation, time dial is equal to 0.155577 seconds. So an accuracy for time dial for usually for majority of smart relay is 0.01. So I can set my time dial to 0.16. So let's go and take a look to our simulation here and see what do we have here. First, I try to set up my relay specification. So this one is my relay A, this one is backup relay. So as you can see, curve is C2, pickup is 3, time dial is 0.16, and I use Schweitzer 0501 relay. And I try to set TCC to 10K. I just try to cut my curve after 10. I don't need to review my current curve after 10K amp. And I try to turn off all overload protection and also instantaneous protection. So I did same things for the relay B as the main relay. So it's Schweitzer 501, curve is C2, pickup current is equal to 5, and time dial is equal to 0, 1. So to use the star coordination and protection, so I try to use just relay B. I need to click on star protection and coordination and try to press create a star view. I try to set everything, and to be sure I try to adjust my crosshair to a point very close to maximum fault point is 2800 approximately, and you can see the delay is approximately 0.29 seconds, is completely based on my calculation. So if you would like, you can move up and you can move down, and you have some idea about maximum and minimum current and maximum and minimum time interval. So to continue, I try to pick both relay, click on star protection and coordination, and click on create a star view and set all specification. So as you can see, I have two relay. So one of them is relay B. This one is my main relay. You can see all specification related to this relay here. And the other one is relay A, and definitely you can see all specification related to this relay. So I'm going to do same thing similar to my previous video. So I'm going to click on this main section, main part, and I'm going to click on this tab, fault insertion. I'm going to grab this one and connect this one to somewhere close to bus C. So, and take a look. CB1 or C circuit breaker B is tripping first, and circuit breaker A is tripping after circuit breaker B. So that means it's backup relay. If you would like to see something about this condition, you can click into on this tab is sequence viewer, and I have some number. So for this fault current 1361, time for the main relay is 784 millisecond, and time for the backup relay is equal to 1702 millisecond. So definitely you remember my explanation for the ETAP. I can't apply the fault somewhere in the middle of transmission line. The only solution I have here is to play with transmission line length. So I prefer to adjust the length to 130 kilometer and run my simulation again. Hopefully for this length, my current is very close to minimum current. So as let's take a look, my current here is 1178, is very close to the minimum fault current for this system. And my calculated time or simulated time for the main relay is 996 millisecond, and the trip time for the backup relay is equal to 2243. So, and if you would like, take a look to the maximum fault current, double click on the cable and try to length the cable length to 1. So the current I have here in this condition should be very close to the maximum current. So I am applying the fault to the same bus. Take a look first, circuit breaker B is tripping, after that circuit breaker A, And take a look to the time. Trip time for the main circuit breaker is equal to 293, very close to my calculation. And trip time for the backup circuit breaker is 588, very close to my calculation. Keep in your mind, I set my BC or BC transmission line length to 1 kilometer. If I try to adjust this one to 0 or shorter value than 1 kilometer, my number is exactly based on the calculated value. So let's back to our calculation and see what is the problem of this coordination. So I try to calculate time difference for this example for the minimum fault value. Definitely you remember I try to set up my time dial based on maximum current. And now I try to use or do some calculation based on minimum current. So minimum current 1179 and the trip time for the main relay is equal to 0.9941. I believe few minutes ago I showed you this value as a part of my simulation by ETAP software. And the trip time for the backup relay, so for same fault, minimum fault, relay current is equal to 5.895. Tap is equal to 3, so mort is equal to 1.965, and time dial 0.16, and trip time for the backup relay is equal to 2.238, and difference between these two values between trip time for the main relay and trip time for backup relay is equal to 1.244 seconds. So let's back and see. For the maximum fault current, difference between these two is something less than 0.3 second. Is 0.2 plus 5 cycles. 6 cycle is equal to 0.1 second. So it's approximately 0.283 83 second. And take a look to my calculation for the minimum fault current difference between these two times, trip time for the main relay and trip time for the backup relay is equal to approximately is 1 and 2 1.2 second. I'm looking for better solutions, so I would like to do the same calculation, but instead of C2 curve for the main or backup relay, I'm going to use C1 curve and see what will happen. So a majority of part of my calculation is exactly the same. I can calculate the tap for C1 exactly based on same formula, based on same logic. So prefer tap for backup relay. No, instead of C2, I'm using C1 is equal to 3. So I need to calculate the time dial based on the maximum current. So maximum current 2834. And definitely you remember the trip time for the main relay based on C2 curve is equal to 0.289 seconds. So I try to consider the trip time for the backup relay. So I add that 0.2 second coordination time interval, 5 cycle relay operation. So trip time for backup relay should be 0.5 second. But difference is here. Instead of C2, I'm using C1 curve. And C1 curve has different formula. So I try to use C1 curve formula and try to calculate time dial. So based on this formula C1 curve, my calculated time dial is equal to 0.1289, and I prefer based on accuracy of time dial for a smart relay, I can move or I can work with 0.13. So let's what's going on here. So I'm going to click on my backup relay, and I'm going to go to OCR, overcurrent relay protection. Instead of C2, I'm going to pick C1. My pickup is the same and my time dial is equal to 13, and press OK. And let's go to the curve I have. So take a look. My curve for this example is a little different with the curve we had for the other one. So let's move this one to somewhere close to 13. So 3,000 amp. So if current is 3,000 amp difference, time difference between main relay and overcurrent and backup relay is equal to 0.286. So 0.86, definitely you remember, is 0.2 plus 5 cycle, coordination time plus 5 cycle. And if I try to move this time difference up, somewhere close to 1000, take a look. In 1000, difference is approximately 0.36 second or somewhere close to this one. So what I did here, instead of two same curve, I try to use two different curves. So, and as you can see, the trip difference time for maximum fault current and minimum fault current is very close. So for both condition, trip times for the backup relay is approximately 0.3, 0.4 second after the main relay. So I believe this one is better solution compared with my previous solution. So combination of C1 and C2 is better. And if you have any question, keep in your mind this diagram is logarithmic diagram. So take a look. Distance between this point and this point is from 100 to 300 is 200 seconds. And same distance from here to here I have from 1 to 3 is 2 seconds. So this duration, this difference is equal to 2 seconds. That same duration in upper side of the curve is equal to 200 seconds. So the thing I'm trying to say is this very short difference in upper side of the curve is approximately equal to this longer distance in bottom side or end side of the curve. So let's take a look to the final calculation for this condition. So I try to calculate the time difference for the minimum current. So definitely you remember this part of calculation. So 0.9941 second for minimum fault for the main relay. For backup relay, I'm using different curve. So I try to put my time dial 0.13 and morts for the minimum current 1.965. And as you can see, the trip time is 1.338, and difference between trip times for backup relay and main relay is approximately 0.3439 seconds. So for the minimum current, difference is approximately 0.35, and for maximum current, difference between trip time is approximately 0.29, 0.28 seconds. So they are very close. So thank you so much, and don't forget to subscribe my channel. My channel is Power Tech Academy, and if you have any question, you can add your question in comment section, and don't forget to, if you like, please press the like button. Thank you so much.